What's up, everybody? I am the Nature Hacker, and this is your world. So today, what I want to talk about is electric cold fusion again. And I want to call it cold fusion because there is fusers, and they do use electricity to create heat to create fusion. But the type of electric fusion we're talking about here is cold fusion. There doesn't need to be very high temperatures for the fusion to happen. So the other day I was talking to you about this lattice here and how when you get an oxygen vacancy in this crystal structure from a strong electric charge, you get the three irons. Like if you look at this oxygen here, for example, you get the three irons connected to it collapse in on each other and form, along with two oxygens, form plutonium 197, which decays into gold 197. And I don't know if I mentioned that I was a little worried about my theory because it would require not only 15 positron emissions, aka electron captures. I don't believe in positron emissions. I don't believe in positrons, but I do believe that it's electron captures. And just a quick aside, an electron capture is when a proton gets turned into a neutron by catching an electron. So the proton's neutralized from a positive charge to a neutral charge, it emits an X-ray. Now, they found that sometimes when this process seems to happen, it actually emits a gamma ray. So they're like, oh, what's actually happening with the gamma ray one is that it's emitting a positron, and the positron hits an electron, and then it annihilates into nothing because something plus something equals nothing, and you get a gamma ray. How about no? How about actually it just absorbs, a higher energy electron with extra photons inside of it, and then it emits a gamma ray. Okay, so it's still an electron capture. The protons are turning into neutrons, but it's just it's a higher energy process than so the aka positron emission is really just an electron capture that's a higher energy process than an electron capture. So anyway, so I was a little worried because if that, we were talking before about iron 56, 3 iron 56 and 2 oxygen 16s, well, that makes 200 atomic mass, and gold is 197. So I had to kind of do some hand waving and say, well, maybe as it's doing all this electron capture to get down in its proton count, from 94, I believe, to 79, maybe it has to emit some neutrons along in that process. But that's kind of just like, that's not really any, proven science or anything. That would be a whole new theory, and, try to stay away from that. So what I was thinking, though, is I'm like, well, if we see a lot of mercury, because mercury's atomic mass is 200, so if I'm right, and it's 3 irons plus 2 oxygens equals gold, then we would probably see a lot of mercury, because mercury's atomic mass 200, and that's what those three things add up to get, is 200. So I was like, well, if we're using iron 55, then to make the gold, then that would make 197, and that would make gold just straight up. But iron 55 is not easily found. Iron 55 has a half-life of 2 years, so it really isn't a naturally occurring thing. But what can happen is when iron 54 or when iron 56, which are two common isotopes of iron, when they're hit with, which actually iron 54 and iron 56 make up like 95% or more of all iron. So when those two things are hit with neutrons, they actually decay into iron 55. Now both of them will turn into iron 55. Iron 54 will capture a neutron and turn into iron 55. Iron 56 will capture a neutron and give off 2 neutrons to form iron 55. So both of them, when hit with neutrons, will turn into iron 55. Now that's really convenient for us because we already figured we're going to need neutrons. Okay, so if we could use iron 56 to make gold, then we wouldn't need any neutrons. All we would need is this iron oxide, hematite. All we would need is that and a strong electric charge. But that just doesn't sound like enough. It makes sense that it would require also neutron radiation. So that means that these irons have to be iron 55s, and so that means that this structure here has to be bombarded with neutrons and a strong electric charge in order to get it to collapse into gold, to fuse, electrically cold fuse into gold. So I was like, well, that just doesn't make sense because, let's say we're finding gold, if it takes iron 55 to make it, it's not going to be pure gold because all of this isn't going to be iron 55. As hard as we try to bombard this with as much neutrons as we can. And interesting side note, neutron radiation has been found in earthquake zones and in the cracks from earthquakes and stuff. They find neutron radiation, and guess what also is always around earthquake zones and stuff? Gold. So that's another little confirmation that this theory is correct. Okay, now I was like, well, so if we're really going to use if we have to use iron 55 to make gold, then that means that we're going to get a lot of mercury made, because a lot of these aren't going to be iron 55. They're going to be iron 56, because that's like 90% of all iron is iron 56. So we're not going to perfectly convert all of these to iron 55. So that's just a difficult thing. It's like, well, gold's, it's 24 karat gold when you find it in the ground, right? It's pure gold. Well, that actually isn't the case. And actually, probably the biggest contaminant in gold is, guess what? Mercury. Mercury is a huge contaminant in gold, and as soon as I saw that, bammo, I'm like, oh my gosh, this is confirmation, because this is what I would predict. This is what I did predict. That's the reason I was searching for the fineness of gold, the carat of gold in the wild, is because I figured that if it was iron 55 if we needed iron 55 to make gold, we're going to be making a lot of mercury, because a lot of it, the iron is going to be 56, and that's going to add up to atomic mass 200, which is mercury. So I predicted that. I predicted that if we did need iron 55 to make gold, that we're also going to see a lot of mercury in the gold, because not all the iron is going to get converted to iron 55. A lot of it's still going to stay iron 56. So it turns out mercury is huge. I found one study on the composition of placer gold saying that mercury content in this gold was high, that the carat of gold found naturally was low, and that there was a high amount of mercury in the gold. Other studies I found, they're in the description below, say that that there's zones in the gold that are depleted in mercury. Another different study said that when gold erodes and is fumbling around for thousands of years, that its purity goes up. All of the mercury, silver, copper inside of it will dissolve out somehow or another, and the gold will be more pure. This is all. I'm not claiming this. This is in the description. Studies in the description say all these things. And another, like I said before, another one said that there are mercury depleted zones. That means that the mercury has been evaporated out. Mercury is kind of a transistory element. It has been evaporated out or been eroded out somehow. So mercury is a big deal in gold. Mercury is one of, if not the biggest contaminant in gold, and that's exactly what I would predict. So really that confirms to me that, plus the finding that earthquakes have been found to be linked to neutron radiation, and obviously gold is linked to earthquakes. Just look at California gold. That's obviously earthquake linked, and I'm not making this up. I'm simply saying I've found in the research that all our earthquake zones are places where gold is found, along with places with a lot of sulfide, along with places with a lot of telluride, along with places with a lot of quartz, along with places with a lot of hematite. All of these things add up to support this theory. And the final theory really is that it takes three things to make gold. Hematite, number one. Number two, neutron radiation, converting the iron 54 and iron 56 into iron 55. And thirdly, a strong electric charge to create oxygen atom vacancies so that those three irons around that oxygen and two more oxygens can basically implode into electric cold fusion generated gold and other elements. Obviously we're getting mercury created as well from non-isotopic iron. Well, yeah, everything's an isotope, but from iron 56 it will produce mercury. From iron 55 it will produce gold. So obviously you can go out and try to buy iron 55, which actually Oak Ridge Nuclear Lab sells iron 55. I wonder if they know that it can be used to create gold. I think they do, and I think that's the reason they're selling it, is because some companies actually buy it to create gold. But I think that we can create the iron 55 a lot easier and cheaper by just bombarding it with our own neutrons, and we can create neutrons pretty easily by just electrolyzing in an acid solution. You know, like I said, I don't know, maybe in the comments, I electrolyzed in a very dilute sulfuric acid. Like I took distilled water and put just you know, maybe a teaspoon of sulfuric acid into a big jar with 2 iron electrodes in it. I started electrolyzing. Bam, that thing heated up so fast, so much faster than an alkaline electrolysis. And alkaline electrolysis is known as pretty much the best, you know, for producing hydrogen, oxygen, and stuff. But when you use acid instead of the alkali, you're getting a lot more heat. And guess what extra heat is linked to? Neutron radiation and cold fusion. So, and not only that, I could feel the radiation, you know, because I've had somebody's like, what, you have superpowers, you can feel ionizing radiation? Well, I'll tell you, I had kind of like a food poisoning with Campylobacter perfringens. And this causes peripheral neuropathy, so it causes a tingling sensation in the arms, legs, whole body, and everything. So I had that a few weeks ago, but as soon as I started doing some of these, you know, nuclear type experiments, I started getting that tingling coming back, and I could definitely link it with the acid electrolysis. I didn't get the tingling from alkaline electrolysis, but I did get it from acid electrolysis. I had to bury that thing in sand, wet sand, a lot of it, to block that, so I didn't feel that radiation anymore. So anyway, the way I see acid electrolysis as creating neutron radiation is because those protons, those H pluses, those are nice little protons, easily accessed protons. That's what NASA uses to create neutrons, is H plus protons. So acid is full of H plus, because that's what acid is H plus. So you have these H pluses floating around. You got this electric charge coming from the electrode, from the electrolysis. It's converting those H pluses into neutrons that are going up, zinging off. So we're creating our own neutrons to create iron 55 in an acid electrolysis. My previous method of talking about you know, the hydrogen sulfide gas and the quartz crystal and the hematite inside that, you know, that's not going to be really producing any neutrons. So that method might not work without the neutrons produced in earthquakes. So, you know, all that stuff is found in earthquake zones, and you know, the hydrogen sulfide gas, hydrogen telluride gas, and all that. So it might need the neutrons from the earthquake. So a better you know, practical way to test this might be just electrolysis, a slightly acidic electrolysis. I was using sulfuric acid, just very dilute sulfuric acid. And what I was doing is I'm putting a 30-volt power supply on it and trying to get about 10 amps. So I put in just enough acid so that when I crank the amperage up, that I get 30 volts at 10 amps. And you can do that with any type of, you know, 30 volt power supply, you know, a tunable power supply that you find on eBay or whatever. So 30 volts, 10 amps seems to be good for producing neutrons. You use 2 iron electrodes in there, and what you'll get is you're going to get the you're going to get the iron oxide, this hematite form on one of the electrodes, just from because it's being oxidized. The anode in this case is oxidized in electrolysis. So you're going to get this. You're going to get the neutrons from the acid being converted into neutrons. And what is the final thing you need? You need a strong electric charge, which you can get with, obviously, electrolysis, so you'll get the electric charge in there. So we got all of the elements together. We got the neutrons, we got the electric charge, we got the hematite, the iron oxide, the rust. That's what we're making gold from, is rust. So we've got all of the things there. Now, how do we make it better? Well, we can try to capture the neutrons instead of bombarding outwards and trying to block it with wet sand. What we can do is put some big fatty electromagnets or neodymium magnets around that jar, and we know that neutrons are affected by magnetic fields. That's how, like, neutron imaging is done in the medical field. I think MRI, is that neutrons? I don't think so. There's a neutron a type of imaging out there, so they use magnetic fields to create neutron beams. But anyway, we can use big magnets around the jar to help confine the neutrons and help get them to hit into the iron and create more iron 55. So that's one thing we can do to improve it. Another thing might be AC electrolysis. AC alternate. Your anode is going to switch to cathode, and cathode to anode 60 times a second. Now that's perfect for what we want over here, because what we want is this iron oxide is going to form at the anode, which is the place it's getting oxidized. We want the iron oxide on the cathode. Now how do we do that? We switch the polarity. We get this to build up on the anode, and then we switch the anode, so that's now the cathode, which has the electrons. So we create this on the anode, we turn the anode into a cathode, and that electricity hits this, creating the oxygen vacancies, and obviously we got the neutrons going as well. Yeah, and that will also be a better thing. And maybe 60 hertz isn't the best. Maybe 4 hertz, 4 cycles a second. Maybe 1 hertz. We know from one of these papers that I've referenced in one of my other videos is that they find out that with 30 volts at least, they got neutrons happening for 3 seconds after they ramped up the voltage. So they go from 0 to 30 volts, and they get neutron release for 3 seconds. So maybe a switch every 3 seconds is the best, something like that. But I'm just going to try an AC power supply. It's easy to buy. It's really hard to switch a DC power supply from anode to cathode. It's something you have to manually do with clamps, with your positive and negative clamps. They're clamped on these, and then you have to swap them, so that's something difficult to do every 3 seconds or whatever. So I'm going to use an AC power supply. Hopefully that 60 cycles a second, it's long enough to produce some of this and also hit it with the electricity as it switches from anode to cathode. So we got all of this stuff. We got the neutrons, we got the electricity, we got the iron oxide. Now it just comes down to improving the efficiency of the process. So hopefully we can produce gold, first of all, enough gold to recover. Something important to get is some stannous chloride solution so that you can test your solutions to see if there's any gold present. So you might have to look up some gold refining stuff. If you do try this, this method does not have any toxic gases, so it's safer, definitely, but you do need to worry about the neutron radiation, so you're going to want to have like a big pot of wet sand that you have your jar down inside of that, so that you're not exposing yourself to neutron radiation. So if you have any questions, let me know in the comments below. If you happen to be watching right now, I can answer some questions. So let's see if anybody is here, and it looks like we have nobody in the chat. So anyway, it was fun. We have one person watching, so thank you for watching. Appreciate it. Let's together do work.